All right, this is my presentation on electric fields for LB 274. All right, electric fields. So the definition is a region around a charged particle or an object within which a force would be exerted on other charged particles or objects. I chose electric fields because I actually very much enjoyed electric fields and forces the most throughout this class, and I was genuinely interested to know more about it historically. A lot of STEM courses mainly focus on the concepts, but not always where they were derived from. Learning where the concept came from and the people who discover it gives a greater appreciation for the subject. All right, so today we are going to be talking about Michael Faraday. He is one of the important figures in discovering electric fields. He was born September 22nd, 1791 in Newington, Surrey, which is now a part of South London, and he died August 25th in 1867. The challenges that Faraday faced were he had no formal education. He was the son of an English blacksmith. Faraday's family was not well off, and he had three other siblings. His family barely had the funds to feed their children. Their father was ill and incapable of working steadily as a blacksmith. Faraday once recalled that he had been given one loaf of bread that had to last him a week. What Faraday did to make his life better. Faraday apprenticed at 14 years old at a bookseller and read every single science book and attended lectures given by various scientists at the Royal Institute. Faraday learned how to read, write, and cipher from going to the church's Sunday school. His family belonged to a small Christian sect which provided spiritual guidance to Faraday throughout his life. Faraday got his big break when he attended a lecture given by Sir Humphry Davy at the Royal Institution. He then asked Davy for employment, showing him all his notes and drawings. Davy told him there was no opening for employment. When one of his laboratory assistants got dismissed, Faraday was offered a job. Once Faraday was able to get a chemical assistant position at the Royal Institution, his career started taking off. He accompanied Davy on an 18-month European tour, meeting many influential scientists. Faraday worked on and off for 10 years trying to prove that a magnet could induce electricity. He repeated Oersted's experiments on how the current in a wire will deflect a compass needle. After this, he performed experiments that show clearly that electromagnetic field is equal to the rate of change in magnetic flux. Faraday worked with models. He began doing his own research and submitted 2 papers on chemistry to the Royal Scientists in 1820. In repeating Oersted's experiments, Faraday found that a magnet also exerts force on a wire, carrying electric current in 1831. The model that Faraday created included iron fillings and magnets. He invented the concepts of magnetic and electric field lines. His model included 2 coils of wire wound around opposite sides of a ring of soft iron. The first coil was attached to a battery, and when a current passed through the coil, the iron ring became magnetized. A wire from the second coil was extended to a compass needle a meter away. Faraday showed changes in the magnetic field around the first coil, responsible for inducing current in the second coil. He also demonstrated that an electric current can be induced by moving a magnet, by turning an electromagnet on and off, and even by moving an electric wire in Earth's magnetic field. Faraday was elected to the Royal Society in 1824 and was made director of the laboratory at the Royal Institute in 1825. Faraday made many other notable contributions. He devised the first electrical generator. He discovered the correct laws of electrochemistry. He found that when light passes through a medium, a magnetic field will rotate the direction of the oscillating electric field. Despite all of his achievements, Faraday remained a modest and humble person. He declined to be knighted or to receive honorary degrees and only accepted a small pension during his retirement in 1858. A possible question for the class is, what is the value of the electric field at point C? The way that I answered this was I used E equals KQ over R squared, and then you just do that for both E1 and E2, and then to find E net, it's just E2 minus E1. I think it goes with my subject. And thank you for watching.